Okay, this is the final problem that I'll be explaining for part and project network analysis. We'll not be discussing crashing right now because maybe later in some other video we can discuss that. But yes, so we'll be explaining part with this is the second example, and here we'll be using dummy activity. So I have just written the information. Activities are this: A, B, C, D, E, F, G, H, and I, and the predecessor is given. So from that we will be writing, and T0, Tm, and Tp are given. I'll be doing a little bit faster in this case. So A successor is, I think, B, C. So A successor B, C, and F. B successor is D. C successor is also D. D successor is G. E successor is I. F successor is I. G successor is H. And H successor is I, and I do not have any successor. So that means starting activity is A and end activity is I. So let's draw the network. If you have seen that, I have already kept a space because I know that there will be a dummy will be required for this particular problem. As you can see this particular D and E. D's predecessors are B and C, but E's predecessor is only B. So this particular information tells you that you will require a dummy. Otherwise, it will be difficult because from A, both B and C are coming out, but for D, both B and C has to be joined together. So that tells you that here is a requirement of dummy will be there. So let's try to draw. So initially that is A. Initially this is A. Then from A, B and C comes out. So A, B, C. In fact, B, C, and F. F will also be there. So this is F. So from B it will be let's write okay. So from B there will be E, and D is from B and C. So B, and here we require a dummy. So I am denoting that D1. So B, C comes together, and from there D is there. So D, E, F is from A. We have already drawn. F is from A. Then G is from D. Then G is from D. So G is from D, and H is from G, and finally E, F, and H comes together to get I. So F is coming from here, H is coming from here, and E is coming from here. So that is the. So let's put the numbering 1, 2, 3, 4, 5, 6, 7, and 8. So let's get back and check. A's predecessor, no predecessor. Successor is B, C, and F. No predecessor. Successors are B, C, F. B's predecessor is A. Successor is E. Sorry, there is some mistake. Yes, I have missed. Here is B's successor is D, E. Yes, I have made a mistake over there. So yes, B's predecessor is A and successor D and E. B's predecessor is A and successor is through this particular dummy. This is the D is the successor and E is the successor. Fine. C's predecessor is A and successor is D. C's predecessor is A. C's predecessor is A and successor is D. E's predecessor is B. Successor is I. E's predecessor is B and successor is I. Fine. F's predecessor is A and successor is I. F's predecessor is A and successor is I. G's predecessor is D and successor is H. G's predecessor is D and successor is H. H's predecessor is G and successor is I. H's predecessor is G and successor is I. Predecessors are E, F and H and there is no successor. I predecessor E, F and H and there is no successor. Fine. So now let's calculate T. Yes, since there is a dummy D1, so I'll put the dummy D1 over here. And let's write down the numbering. So A is from 1 to 2. B is 2 to 3. C is 2 to 4. D is 4 to 5. D is 4 to 5. D1 is 3 to 4. D1 is, should have written D1 before D. E is 3 to 7. E is 3 to 7. F is 2 to 7. F is 2 to 7. G is 5 to 6. So let's calculate. So putting then H is 6 to 7 and I is finally 7 to 8. So I is 7 to 8. And as we have said, D1 is the dummy activity which does not require any resource or time, so we put the duration of D1 as 0 and then we'll calculate T using the formula we have discussed in the previous video. 12, 15 and 18 gives you 15, 9, 9, 9 gives you 9. So 13 into 4 is 52 plus 13 is 65. 65 plus 9, 31 is 96. If you divide, it is 16. So this is 0. 3, 4, 5 gives you 4. 7, 7, 7 gives you 7. 8, 12 and 14. 12 into 4 is 48 plus 8 is 56 plus 40 is 96. So this gives you 16. 17, 7.5 into 4 is 30. 37. 37 plus 17 is 54, so this gives you 9. 9, 10, 17 is also gives you 10 into 9 is 10 into 4 is 40, 49. 49. 49 plus 17 is 66, so it gives you 11. So you calculate sigma square 2 by 6 is 1/3, that is 1 by 9. 18 minus 12 is 6. 6 square is 6 by 6 is 1. 1 square is 1. So this is 0. 13 minus 13 is 18. 18 by 6 is 3 square is 9. This is also 0. So 2 by 6 is 1/3. 1/3 square is 1 by 9. So this is again 0. 40 minus 8. 40 minus 8 is 32. 32 by 6 is 32 by 6 is 16 by 3. 16 by 3 is 256 by 9. 16 square is 256. 3 square is 9. 17 minus 7 is 10. 10 by 6 is 5 by 3. So this is 25 by 9. And finally 17 minus 9 is 8. 8. 8 by 6 is 17 minus 8, 9, 9, that is 17 minus 9 is 8, 8 by 6 is 4 by 3, so this is 16 by 9. So we have drawn the graph, we have already calculated the values of T and sigma square, and let's now calculate the critical path. As we have said, in case of part, we will be calculating the critical path using the values of small t, which is the expected completion time of the project. So I have already we have already drawn the graphs, and let's denote by the node. So A is from 1 to 2, B is from 2 to 3, C is from 2 to 4. Where is C? C is from 2 to 4. Then we have put this. Now we will put the dummy D1 as we have put it in the dotted line in the graph. So dummy, we have written dummy D1 as 3 to 4, and as we have said earlier, that dummies are the activity, fixed research activity which does not require any resource and time. So we have put the values of T of dummy as 0, and the variance is also put that as 0. This is only required for proper logic of the network, so we have put accordingly. Then we have written D is from 4 to 5, E is from 3 to 7, F is from 2 to 7, G is 5 to 6, F is from 2 to 7, E is from 3 to 7, so we have written H is from 6 to 7, and finally I is from 7 to 8. So we have already written the T and sigma square as we have calculated earlier. Now we'll calculate the critical path by using earliest and latest time. So as we have said, everything that starts from 1 starts from time 0. So 0 plus 11 is 11. As we are using the formula, we have already stated that early finish time equal to early start time plus Tij, and latest start time is latest finish time minus Tij. So we are just using the same formula and again. So 0 plus, this is my Tij in this case, after we have already obtained the Te, expected time, completion time of each activity is T. So 0 plus 11 is 11. Then from 2, all the activity starts from 11. So all the activity starts at 11 from the node 2. So here 2, 2, and there is 2. So this is 11, this is 11, and this is also 11. So 11 plus 15 is 26. 11 plus 9 is 20, and 11 plus 7 is 18. Then this is the D1 is 3, so we'll go back where I have got 3. So we have got 3 here, that means 26 comes here. So everything that starts at 3 should start at the time point 26. So here it is 26, here it will also be 26. So 26 plus 0 gives you 26. Then for 4, yes, 4 we have got two values, 20 and 26. So as we have said, so refer to the figure. This is one way of coming to 4, and this is another way of coming to 4. So we can only start everything at D when all the previous activities are completed. So D can start only at 26 and not in 20. So in 4 we are having two different values, 20 and 26. We have to take the maximum. So we put 26 over here. 26 plus 16 gives you 42, and 3 here. So 3 is already we have put 26. So 26 plus 4 gives you 30. Now 5, where we have got 5, we trace back where we have got 5, we trace back. So here this gives you 42, so 42 is here, right? 42 here. So 42 plus 16 is 58. 42 plus 16 is 58. Then 6, where did I get 6? So here it corresponds to this value 6. 6 where we have got, so we have got 6 here, so it's 58. 58 plus 9, 58 plus 9 is 67. So at 7 there are 3 values. One is 30, one is 18, and one is 67. 30, 18 and 67. So this one path, this one path, this is another. So that's why we have got 3. That's why we have got 3 values from this particular path, this path, and this path. That's why we got 3 values at 7. So we can only start any activity from 7 when all these activities are completed. So that is 67, and 67 plus 11 gives you 78. So that means everything that will be completed at 8 must be at time 78. So now we will be doing the backward pass. We will be moving backward. So for that we only need the value 78 over here. So latest finish time at 78 is latest finish time at 8 is 78. So we put something over here. Yes, and then we calculate the back we will backtrack. So backtrack. So 78 minus 11 gives you 67. 78 minus 11 gives you 67. So that means everything must be completed at 7. Everything must be completed by 67. So latest finish time at 7 is 67. So I put 67 here, 67 here, and 67 here. So these are the 3 points where 7 appears. So I am writing 67. So 67 minus 9 gives you 58. 67 minus 7 gives you 60, and 67 minus 4 gives you 63. Okay, fine. Then here is 6. So I have to end at 6. What we have to finish activities at 6. So I trace back 6 where I've got 6. So I've got it here. So that means 58 should come here. So 58 minus 16 gives you 42. 58 minus 16 gives you 42. Okay, fine. Then we have to write the latest finish time at this point is 5. So this point corresponds to the node 5. So 5 where I have got 5, I trace back here. So this gives you 42. 42 is my latest finish at 5. The latest finish time is 42. So 42, if you subtract 16, you will get 26. You get 26. Fine. So that means at 4 all the activities must be completed at 26. So then these 2 values are at 4. So 4 is, this is 26. This is also 26. So 26 minus 0 gives you 26, and 26 minus 9 gives you 17. 26 minus 9 gives you 17. Fine. Then 3. Then I have to put 3. So 3 where I trace back. Here is 1 3. Here is 1 3. So this value corresponds to 26, and this value corresponds to 63. So we have to, when we are moving back, we have to take the minimum. We have to take the minimum. Refer to the figure. Again, so we are referring to the figure. So that means at 3 the minimum value will be 26. So if you subtract 26 minus 15 gives you 11. 26 minus 15 gives you 11. Then this is the latest finish time at 2. So 2, where did I get 2? 2 we have got 1, 2 and 3 values. So what are the values? 11, 17 and this is 60. So 11, 17 and 60. So that means we have to take the minimum. So these are the three different paths that are coming. So we have to take the minimum at a particular node. When we are moving backwards, we have to take the minimum, and that minimum value is 11. So this is 11. 11 minus 11 gives you 0. Now I hope I have made the right calculation. So to check, we will be calculating the total float, and to calculate the total float we will be using that formula, that latest start time minus earliest start time, or latest finish time minus early finish time. And as I have told you earlier, that we must calculate both to check whether the values are coming right or not. So 11 minus 11 gives you 0, 0 minus 0 gives you 0, so this is 0. 26 minus 26 gives you 0, 11 minus 11 gives you 0. Then 26 minus 20 gives you 6, 17 minus 11 also gives you 6. Then 26 minus 26 is 0, 26 minus 26 is also 0. Then 42 minus 42 is 0, 26 minus 26 is 0. 67 minus 30 gives you 37. 63 minus 26 is also gives you 37. 67 minus 80, wow, that's a lot of wastage of time. So 60 minus 11 is 49. 67 minus 18 is also 49. 67 minus 18 is 49, I think it's right. So 49. Then 58 minus 58 is also 0. 42 minus 42 is 0. 67 minus 67 is 0. 58 minus 50 is 0. And 78 minus 78 is 0. 67 minus 67 is also 0. So as we have said, all the zeros we will double circle them, and those are my critical activities. So what we get is the critical activities are A, then B, then this D1, then D, G, H and I is the critical path. So we write the critical path as A, B, D, D1, D, G, H and I, and we get capital T as 78 days. And similarly we can so we'll just add, so this is T 19, then 0, 16, 9, 11. If you add 11 plus 15 is 26, plus 0 is 26, plus 16 is 42, plus 16 is 58, 58 plus 20 is 78. So expected completion time is 78 days, and we'll also find out the standard deviation or variance of the project. So sigma equals to square root of 1 by 9 plus 1 plus 0 plus 9, 1 by 9 plus 1 plus 0 plus 9 plus 256 by 9 plus 25 by 9 plus 16 by 9, which gives you root over of 10, so 90. So what we get, so let's use the calculator. So let's use the calculator. I prefer to use the hyper calculator that we have. So 1 plus 90 plus 256 plus 25 plus 16. So this gives you divided by 9 equals to, so that is root over of 373.7 sorry, that's quite a wrong. This is equals to divided by 9. So this, sorry, so it's root over of 43.1. So square root of, so if you put a square root, put a bracket, so it's 2. There is a little mistake, I think. I'm making a mistake. So this gives you 6.57 approximately. So that means standard deviation is 6.57 days. So if you are asked to what is the probability that it will be completed by 85 days, so in that case we can use the formula as Z equals to due date minus T by sigma. So due date is 85 days minus get is 78 days as T, and this is 6.57. So we get as what we get is into, so you get what we get is 1.067. so that means the probability will be, so standard normal curve, say suppose this point is 1.067, so that means the required probability will be this shaded area is the required probability. So the probability that the project will be completed by 85 days is the shaded area of the standard normal curve. So that completes the part and CPM, or the probabilistic model of network analysis, and the deterministic model of the network analysis. We are not discussing crashing over here. Crashing means where we can use some more cost to bring down the time. We are not using or not explaining over it here. Maybe in later videos we will try to explain that. Thank you.